We are looking at 12.4, the normal distribution. So here is what we will be covering in this. We have a lot of pictures of graphs of distributions. So these are the histograms. It's specifically a normal distribution whenever it looks like a bell-shaped symmetrical curve about a vertical line through its center. So if you kind of cut that right down the middle, it's close to being symmetrical. Same thing here, put it right down the middle. So this is the normal bell-shaped curve. The shape of a normal distribution depends on the mean, which we're going to call the mean x bar, and the standard deviation is going to be sigma. These three graphs, so look at the height on each one of these and the spread of them. They all have the same mean right in the middle, but have different standard deviations. So that's what determines the height of it. As the standard deviation increases, the distribution becomes more spread out, but retains the symmetric bell curve. So here is the 68, 95, 99.7 rule. So this is the mean right there in the middle. So that would be x bar. And then we have above the mean, which are positive values for these, which these are going to be called z-scores here in a little bit. And then below the mean are negatives, standard deviations below the mean. Approximately 68% of the data items fall within one standard deviation of the mean in both directions. So see how the mean is going to be right here in the middle. If you go one standard deviation above over to here, one standard deviation below. Anything within one standard deviation falls in this area right here, which is 68% of the data. So we can write this as x bar plus or minus 1 standard deviation, or 1 sigma. 95% of the data falls within 2 standard deviations, so it looks like this. So we'd say x bar plus minus 2 standard deviations. And then 99.7, which is a majority of the data, falls within 3 standard deviations. So we'd say x bar plus minus 3 standard deviations. So our first example is asking to find the height that's 2.5 standard deviations above the mean. So they've given us information. So this is an important thing to pay attention to and write down because it's going to help you. It says male adult heights in North America are approximately normally distributed. Mean of 70. So I'm going to go and write x bar 70. Standard deviation of 4. Find the height that is 2.5 standard deviations above the mean. So if you draw your bell-shaped curve, okay, so find the height that is 2.5 standard deviations above the mean. So if you look back at this, we have 0 standard deviations above the mean. We have 1, and we have 2, and we have 3. So it falls right here. So whenever they say the mean is 70, that's saying this is 70 right here. And so 2.5 standard deviations, so it'd be above 70, 2.5 standard deviations above. So we want to find out what this value is at 2.5. So what we do is we're going to do 70 plus 2.5 standard deviations. So what I did was x bar plus how many standard deviations it is. This is going to end up being called z. So I'm going to put z times the standard deviation. So we can just use our calculator for that. 2.5 times 4 is 10. So 70 plus 10 is 80. So right here is 80. It's above, so we know it's above the mean. So this is more, like the z is some of them that we're going to learn here in a minute, but it's basically a way to show how far away it is from your mean. The next one. The scores on a test are normally distributed with a mean of 110 and a standard deviation of 22. What is a score that is half standard deviations below the mean? So if you look at your little normal distribution curve, you have 0, and it's saying half standard deviation. So we have 1 here, so half would be right there. 0 is represented by 110 because that's your mean. So we're only half a standard deviation away. So we are going to do 110 plus half a standard deviation. So half is like your z-score. This is our sigma. This is x bar. And it says it is half standard deviations. Oh, it says below. So instead of saying plus, I'm going to do minus. So I should have gone the other way. -1. You got to pay attention to that word. All right. So 110 plus negative half times 22. So that's 99. So since it says below, right here would be 99. That's half a standard deviation. Look at the next problem. Use the distribution of male adult heights to find the percentage of men in North America between 66 inches and 74 inches. So we want to find percentage of 66 and 74. So using the rules, it's between these two, which gives us 68%. 68% of men are between the heights of 66 and 74 inches. Let's look at this next example. It does not give us a bell-shaped curve, so we have to draw it. Scores on the GRE are normally distributed. Okay, here's our normal distribution. With a mean of 541, standard deviations, I'm going to just write that. Standard deviation of 122. Use the rule to find percentage of people taking the test who score between 419 and 663. So we know 419 is going to be below, and 663 is going to be above. We've got to find out how far above. So this is 1 standard deviation below. This is 1 standard deviation above. So we know that this is below and above because this is our mean. So we got to find out how many standard deviations it is away. So we would subtract them. So 663 minus the 540. 663 minus 541. 122. So that's 1 standard deviation above. So this is x bar plus 1 standard deviation. So that's at, if this is 0, this is at 1. So we'll do the same thing here. 419 minus 540, 1. This is negative 122. So that means it went down. So it's x bar minus 1 standard deviation. So if this represents 0, this represents 1 standard deviation above. This represents negative 1 standard deviations because it's below. So it falls within 1 standard deviation. So that's 68%. So you can look back at this and you see -1 to +1 is 68%. Okay, now let's move on to z-score. So I kind of talked about it. Z-score is a way to show how far away it is from the mean. And it doesn't matter what your mean is or what your standard deviation. It describes how many standard deviations a mean item in a normal distribution lies above or below the mean. Z-score can be obtained by doing your data item minus the mean divided by standard deviation. So I'm going to call this x minus x bar divided by your standard deviation. Data items above the mean have a positive z-score. Data items below the mean have a negative z-score. The z-score for the mean is 100. So looks like this: 0, 1, 2, and 3, -1, -2, -3. So these are all represented by the z. A 0 z-score means that your x bar is right there. And then above would be +1 standard deviation, +2 standard deviations, +3 standard deviations. And then you can go backwards by subtracting standard deviation. So let's find the z-score for this example. The mean weight of newborn infants is 7 pounds. So x bar is 7. The standard deviation is 0.8 pounds. The weights of newborn infants are normally distributed, so you have your normal bell-shaped curve. Find the z-score for 9 pounds. So we want to find what z is. So z is your data item, so this is x, 9 minus your mean, divided by your standard deviation. So if it's 9, your mean is here, so 9 would be above. So we're not sure where. So whenever you divide this, 9 minus 7 is 2. We divide by 0.8. 2.5. So that means that 9 is 2.5 standard deviations away from the mean. So see how this is 0 and this is 1. This went up by 0.8, which is 1 standard deviation. You go up by another standard deviation, 0.8. And now you go up by half a standard deviation. You get 9 right here. So a 9-pound infant is 2.5 standard deviations above the mean. Okay, let's compute some more z-scores. The set of data items is normally distributed with a mean of 70 and standard deviation of 7. Convert 91 to a z-score. So whenever you have it like this is 91, z 91. So we are going to do x minus x bar divided by your standard deviation. So our x on this is going to be 91, x bar is 70, standard deviation is 7. So we want to look at how 91 compares to 7. So it's above. So it's going to be a positive z-score. So we take what we have been asked to convert. So 91 minus 70 divided by your standard deviation. 91 minus 70 is 21. 21 divided by 7 is 3. So the z-score on this is 3. 91 is 3 standard deviations above the mean. Next one, we have another normal distribution with a mean of 55 and a standard deviation of 10. Convert 60 to a z-score. So 60, we're comparing 60 to our mean. It's above, so it's going to be a positive z-score. We're going to do 60 minus 55 divided by our standard deviation. 60 minus 55 is 5. 5 divided by 10 is half, or 0.5. So it's 0.5 standard deviations of mean. Continue. Scores on a dental anxiety score range from 0 no anxiety to 40 extreme anxiety. Scores are normally distributed with a mean, write that down, 11, standard deviation of 4. Find the z-score for the given score on this dental anxiety scale. So we have 4, so 11 compared to 4, 4 is below, so we're going to have a negative z-score here. So find our z of items 4 would be 4 minus 11, because 4 comes from our x, which x minus x bar, divided by standard deviation. 4 minus 11 is negative 7 divided by 4. You can put that in your calculator. Negative 1.7. So it's below the mean 1.75 times the standard deviation. All right, 20 is the next one. At 20 compared to our mean, it's above, so we're going to have that positive z-score. Z of 20 is found by doing 20 minus 11 divided by 4. 20 minus 11 is 9. 9 divided by 4, 2.2. So it's above the mean, 2.25 standard deviations. Understanding z-score. So IQs are normally distributed with a mean of 100, standard deviation of 16. What is the IQ corresponding to negative 1.5? So since it's negative, we know it's going to be below. So we have, this is 100. That's x bar. Our z on this is 0. So 1 and then 1.5 below. So the way that you would find out what that score is, you'd say x equals our mean plus or minus however many z-scores from our x bar. So on here, we'll do 100. Since it's below, it's going to be minus 1.5 times our standard deviation. That's 76. It's below, oh, that's a negative, by the way. So that's 76 is the value, which is negative 1.5 standard deviations. Let's look at another one. We have a normal distribution with a mean of 600. Standard deviation is 50. We want to find what the value is if z is 2.5. So we're going to do x equals our mean plus 2.5 standard deviations. 600 plus 2.5 times 50. 725. So since it's positive, it's going to be greater than your mean. Okay, percents and quartiles. For a normal distribution, you have where you can cut this into 4 parts, where right in the middle is your median, which is 50% of your data is above the median and 50% is below the median. We can look at percent of items. So let's say right here would be 25, 25, 25, 75% of data would be right here. Using the z-score in the table, you can find the percentage of data items that are less than any data item in a normal distribution. In a normal distribution, the mean, median, and mode all have a corresponding z-score of 0 and are at the 50th percentile. Thus, 50% of the data items are greater than or equal to the mean, median, and mode. So right here is the mean, the median, and the mode for normal distribution. If it's not normal, you can't say that, but this one is normal. If we look at a particular score that's in the 83rd percentile, what does that mean? It means that 83% of the scores are below that score. So you're in the top tier if you're at 83% percentile. So they use percentiles for SAT, ACT scores. They use them for heights and weights whenever, especially whenever you just had a kid, they'll tell you what percentile your child is in for height and weight. Okay. Other types of distributions are called skewed. So this is number of people, weekly earnings. So this is skewed to the right. The tail is to the right. So majority of them are, here's your mean, here's your median, and here's your mode. The relatively few people with very high weekly incomes pull the mean income to a value greater than the median. The most frequent income, the mode, occurs toward the low end of the data items. This is called a skewed data distribution because a large number of data items are piled into one end or the other with a tail at one end. This graph is skewed to the right. So whenever it's skewed to the right here, the tail is on the right. So skewed left would look like this, where your tail is on the left. This is called skewed left. So that is a not normal distribution.